All right, so we begin a new chapter, or sorry, new section in the textbook here. This is going to be 2.3. We are talking about polynomial. Let me spell that correctly here. And synthetic. Division. Okay, so real quickly here, polynomial, sometimes called long division. So before we get into long division, and let's divide it out here. So this would be, first let's start out with polynomial long division. Okay, so let me do this. Let's go back all the way to 4th grade. I'm going to go with 5 going into 483. So can you guys do that? Go for it. Give you guys a whole 22 seconds to do that. Okay, hopefully we are done now. Let's see, 5 does not go into 4. 5 does go into 48. And that goes 9 times. 9 times 5. And hopefully you guys did that already here. You subtract. That's an interesting thing that we subtract because we're getting close to the number, but not over. And what we do is we bring down the next number. Then we say to ourselves, how many does 5 go into 33? That goes 6 times. So what we do is we put the number on top. And then what we do is we multiply that. 6 times 5 is 30. I'm slowing it down because I want you to see something later on. We have that. And then what we do, we subtract again. So this process just keeps on going and going until we're done. And we're done when there's nothing of the number left over, or technically, notice right here that our quotient ends with our dividend. That piece is done there. The 3 and the 6 are on the same spot. There's no more things to add unless we need to add decimals. Or we can finish it off by saying, oh, do you guys remember all the way in 4th grade doing like this, doing R3? Do you guys remember that? Remainder 3. Okay, so what we're going to do, we're going to be more sophisticated. We're going to be 5th graders. So we're going to say, oh, it is 3/5. Remember, it's whatever your remainder is, and we write it as a fraction. So about what is your divisor originally. Okay, so that's it. That's what I have. That is called polynomial long division. Hold on. That is long division. And it's also polynomial because, let's actually take a look at this. Here, you guys decide with me, yes or no. 96 3/4 or 3/5. Is that the same thing as this right here? 90 plus 6 plus 3/4. Is that the same value? Absolutely. That just means this. That means you have 9 10 units, 6 single units, and then what you have is you have 3 over your divisor, the leftovers in a sense, or the remainder over your divisor. Well, this is polynomial division, except what we're going to do is we're going to put in a whole bunch of different x's and x squareds in here, x cubes, but we're going to do the same exact process. Technically, if you think about it, 5 we can actually write as this right here. 5 is something as 0 multiplying x squared, 0 multiplying x, and we're adding 5. This is just your constant term, but it could have been part of a bigger process here. Okay, so let's do this here. Let's do this problem here. We'll call it exercise 1, and I'm just going to call it divide. Okay, usually what happens is you need to do about like 3 or 4 of these, and then you kind of get the hang of it. It just takes a little while to do each of these here. So we're going to divide 6x cubed minus 19x squared plus 16x minus 4 by x minus 2. That's what we're going to do. So putting it to long division, here it is. Our divisor is right here. And this guy is called the dividend. And I'll keep on doing that just so we have the vocabulary down. So let's go x minus 2 over here. And we have ourselves now. What needs to happen here? These guys have to be in order from the highest exponent to the lowest. And it can't be missing any. So we'll do a few ones where things are missing in just a bit here. But for starters, there it is. We got the x to the third has to go first, followed by x squared, followed by x, followed by our constant term. There it is. Okay, let's start. So what we do, and I'm going to start drawing things, and I'm going to start erasing things because we're going to have to see the visual on it here. So first things first is this. What number times x gives you 6x to the third? Or if you want to do it on the side, you kind of do like this. What number times x would make a 6x to the third if you multiplied it? Perfect. You guys are good. 6x squared. And so what we want to do is we want to write it over here because this is technically our x to the third column. This is our x squared column. That's our x column, and that's our c for constant column. So these guys are just really just columns for us to make sure that we're organized. Okay, you guys said 6x squared. Guess what we're going to do? We're going to take that number and we're going to multiply just like we multiplied the 9 and the 5 and the 6 and the 5 earlier. Okay, so the question is 6x squared. I'm going to do it off to the side. You tell me if this kind of helps. All these different multiplications right here. So 6x squared gives you 6x cubed. 6x squared times a negative 2 makes negative 12x squared. Okay, so what we're going to do is we're going to write that underneath. And the question is, what did you guys do in 4th grade when you got to this step? You subtracted, absolutely. What we did is we subtracted from that step. Okay, and here, because we have two terms, we're not just subtracting the 6x cubed, we're also subtracting the negative 12x squared. It's much easier to do it this way. It's much easier to change this to multiply. Oh, so change this to addition. And what we do is we switch all our signs. So subtraction is the same thing as adding opposites. That's what we have here. And we switched it so that it's easier for us just to go little by little. So 6x cubed minus 6x cubed, gone. Negative 19 and a positive 12. If you add them together, you get yourself a negative 7x squared. Perfect. Okay, and here's the process. Next one comes down, and we start all over again. All right, like I said before, it just takes about 3 or 4 times to do these, and then you kind of sort of get the hang of it, just like long division. Get the hang of long division eventually. Okay, so all this gets erased. And we start over again. So what number times x would give you a negative 7x squared? In parentheses, if I draw like this, I put what number? Oh, let me write it. What number times x? Of course, it's going to get more complicated. What number times x gives you a negative 7x squared? Oh, it'll be a negative 7x. Perfect. So minus 7x goes here. I'll erase my little arrows. And we start it all over again. So now the question is, what's that times that? Negative 7x squared is a negative 7x squared. Negative 7x times negative 2 makes a positive 14x. Perfect. And then we subtract. Okay. And again, without subtracting, let's add opposites. So positive 7 here. Ooh, this one, you just kind of scribble out the positive, just put a little minus there. And this guy better go away. All right, I'll do 1 slash for getting things out. 16 minus 14 makes 2x. Let me put that in a different color. All right, 2x. And what else happens? Absolutely, this little guy comes down. Negative 4 or a minus 4, depending how you want to think about it. And now the question remains here. What number times x gives you a 2x? Plus 2 is perfect. So plus 2 times x minus 2 makes 2x minus, oh, look at this, interesting. Same exact number. So if I'm subtracting here, if you get the same exact number or one number minus the same exact number, you know it's going to be 0. You know, everything cancels, right? But if you just want to do the work still anyways for it, just to make sure, let's go for it. We're going to say plus here. We're going to put an opposite of 2, opposite of negative 4, and those guys cancel. So in this case, we have ourselves a remainder of 0. Okay, answer is, what's the answer to this? If I've divided that x to the third trinomial by x minus 2, the answer is 6x squared minus 7x plus 2. Okay, what's the, and sometimes what the book calls this, the quotient. The quotient. All right, let's go on to the next one. All right, let's go with it here. I'm going to just do it real quickly here. Let's follow along. This is example 2 here. So again, looking at x times what gives you x squared. That's x, that's easy. And then so this little process here is x times all this now. So x times x gives you x squared. X times 1 gives you x. And it just takes really, people that are kind of stuck with this, it literally, once you do about 3 or 4 of them, then you're like, oh, that's easy. It just takes just a little bit of practice. And then what we do is we subtract. Do you guys remember how long division took in 4th grade? I was confused for such a long time. Especially like why would you subtract? That's what I didn't get. Why would you do that?
So the way that my teacher finally ended up teaching it was, well, they tried for the longest time to get us to understand. And she finally said, well, subtract because why not?
Because why not?
Yeah.
Okay.
And we started listening to her after that.
That's cool. Wish everything was solved that way. Like, why not?
I mean, you kind of just do it.
So x times what gives you 2x? And then just don't forget to put a plus 2 there. If it's a positive 2, don't forget because you're technically adding the 2 in later on. Okay, 2 times all this gives you 2x. Now this time it's a plus 2. That's cool. Okay, so this time factoring would not work in this case. So we subtract or add the opposite. And again, opposite. And
First one be negative x, not x squared minus x.
so again,
Oh, okay, I see what you're doing. Never mind. Okay.
cool. So we got this remainder of 3. We can put R3. Well, we're more sophisticated than that. We're going to do what we did before, which is put 3 over 5, right? But in this case, it's going to be 3 over
X plus 1.
Perfect. 3 over x plus 1. There it is. There's our answer. We have divided these polynomials. Okay. You guys talk to me. How are we doing? Good. Thumbs up if we're good. Okay. Gotcha. Or thumbs sideways or thumbs down. One of it. You guys have to tell me. Okay. Let's do, next one's the weird one. Let's do the weird one here. Okay, we're not weird. Divide x cubed minus 1 by x minus 1. Okay, got ourselves a little problem. So I'm missing an x squared in here. I'm also missing an x linear form, right? Okay, what do we do? Okay, we still bring in our divisor over here, x minus 1. And as we put in our dividend, what we're going to do is we're going to fill in all the holes. So let's do this here. We're going to plug in x cubed. Since we're missing x squared, what we're going to do is we're going to plug in a 0x squared. That little 0 multiplier just means I'm not adding anything in, but I still got my little placeholder. What should we do next?
Factor, sorry, wait, no, subtract 1.
Oh no, hold on. We're still putting in this guy here. We got to go all the way to -1.
I missed that.
Perfect. 0x, and -1. There it is. Boom. Okay, you guys, give you a 20-second head start on this one. Cool. I'm going to go with it here. So let's see what number times x gives you x cubed. X squared, put it into the x squared pile. And let's see, x squared times that. So x cubed times 1 makes negative x squared. Everybody agree there? And then what we do is we subtract or add opposites here. So plus sign, minus sign, plus sign. Sweet. And that better go away. 0 plus 1 of those x squareds gives us now an x squared. And the next one comes down. And we get to do it all over again. X times what gives you x squared? And then we have x times, hopefully it's getting a little bit more common here. X times x gives you x squared. X times a negative x gives you negative x. We subtract or add opposites, even better. Ding, ding, ding. That's gone. You can cross it out if you need be. 0 plus 1 is just one of these guys. And ooh, nice. That's what happened with number 1 last time. Oh, okay, hold on. Let's see. What number times x gives you x?
1.
Just a 1, a positive 1 this time. And that, if you're multiplying by 1, you're going to get the same exact thing, right? And if you're subtracting the same thing from itself, you're going to get a 0. Nice. There it is. So we divided x cubed minus 1 with a whole bunch of different zeros inside it by x minus 1.
I wish it was negative 3, no, sorry, 2.
I
Then we can factor that down to x plus 2 times x minus 1.
I don't think so. Oh yeah, if it was a 2, yes.
Why are we doing why do we have the addition side when we have the negative?
Say again, Abby, say again, where?
I mean, when it's like plus negative x3 plus x squared, why are we doing that instead of subtracting?
Because if we subtracted, then we would add the negative, so then we reverse it.
Okay, got it.
But notice that each time, yeah, we do have to do this little subtraction piece each time, right? Subtract and add. So I wonder if there's an easier way. Let's see. Hey, you know what I also see? I also see these little, the x cubed, right, and the x squared. All they are really just, are they just placeholders where we want them? So aren't they like, it's just developing those columns, right? That's kind of where we're at. Okay, one more to try. All yours here. Of course, I'm going to throw in some interesting things in here. So divide. Let's see, 8x squared plus 5x plus 3x cubed minus 7 by x plus 2. All right, so when you put it in, again, all the x's have to be there, and the x's have to be in order of their exponents. We're good?
So all the x's are there in this one.
So x plus 2 is good on the outside, and we have ourselves, what goes first?
Can we change it to 3x cubed
Absolutely.
plus 8x plus 5x minus 7?
Got to put them in order, or else it doesn't work right. The multiplication gets all messed up. Then you got to figure out where you're at in the multiplication process. If they are in order, then we get to, then it flows nicely from left to right. And it's interesting too, because in history, we knew the quadratic formula, we knew the a while back, but it wasn't until about the 1800s when we started really developing our knowledge of polynomials. And so it was It was synthetic division being born at that time. So early, maybe 1700s, 1800s. We developed all these different tools for polynomials. And a lot of times, whenever you develop the tools for things and the calculations for things, then you actually start developing other stuff, right? So if you can develop a quick way to find vertices, you can figure out the weight of structure that looks like a polynomial, right? Or the center of the weight. Anyways, let me begin. Hopefully you guys have done it too already. I got myself, let's see, 3x squared on top. And then I got myself a 3x cubed. 3x squared times 2 makes a 6x squared. And we are going to subtract or add opposites. That's cool. Okay. Let me pause there. Raise your hand if you are done. You guys are too fast. Okay. 2 times, so x times 2x gives us that. So 2x squared. It's kind of interesting too, because really the faster way to do it, right? Because whenever you figure this one out, you already know this is right here over here, right? That's the whole point, right? So you're kind of like, you don't have to multiply again in your mind. You just want to get this guy to be that 4x over here. And subtract, add opposites, done. I give myself x, 7. What do you guys say, plus 1? Plus 1. That has to be the x. That's going to be a 2. And then we add opposites or subtract. And hey, we got ourselves a negative this time. Everybody okay with the negative? So all we have is we have a minus 9 over x plus 2. Okay, so the question was, can I do this faster? And I realized a few things here. I have to somehow put in the negative already. So notice that little negative, because I keep on subtracting. I plug it in, then I keep on subtracting. So the question is, how do I put in the negative? Second thing is, I noticed that, yeah, the x cubed, x squared, those are really just placeholders for my columns. That's all. I could have just wrote 3, 8, 5, and -7. As long as I kept them in the columns, I would have been just fine. So born in the 1800s, I believe 1800s, it was something called synthetic division.
I've heard about this.
Ooh, this is going to be cool. So let's divide. Let's actually do the same exact problem. Let's divide. How did I write it? I wrote it as what? 8x squared plus 5x plus 3x cubed minus 7 by x plus 2. Are we good? All right, how do we do this here? First of all, I got to figure out how to put the negative in there. And so what we figured out is this right here. Let's take this and set it equal to 0 and solve. If I subtract 2 from it and I use the -2, doesn't that in effect give me my negative inside my equation? Love it. That's so cool. Okay, so let's bring this over. We're going to do this. We're going to put this on the outside. And let me see this. There's actually 3 different notations for synthetic division. Oh my God. Okay, yours does it this way. Okay, so what we're going to do is we're going to do an upside down division symbol. It goes upside down now. Okay, instead of putting in the x's, all we're going to do is we're going to go from highest to lowest on the x's, but only put in your coefficients. That's it, just the coefficients. So highest one is x cubed. Coefficient of x cubed is just the 3. We good? Next one. Oh yeah, 2, but what's the coefficient? So I need this guy. I need this guy now. I need next. 5. I heard 5 is the next one, right? We're just going to go down. So x cubed, we took care of the 3. X squared, we took care of the 8. X to the 1 is the 5. And then the constant term right over here. Sweet. You guys ready? Super fast. Here we go. We're going to add down. So that's the 3. And all we're going to do is we're going to take this -2, and I'm putting in arrows, but you guys don't have to put in arrows. We're going to add down, and we're going to multiply back up. So 3 plus nothing, there's nothing there. 3 plus nothing is 3. The -2 times 3 is -6. 8 plus 6, 2. -2 times 2, -4. 5 plus -4, 1. 1 times -2, -2. Add those up. And this guy's a special one. We actually make the last one into like a little box. That's a special guy. Okay, think to what the answer that you guys got here. Look back at example 4. How can we write example 4 answer in light of exercise 5? What's our answer for 4? -9, right? Over x. So real quick here, guys, these little numbers right here. See those in exercise 4? Absolutely. So we have this situation is that's our remainder right there. That's our constant term. 1 is our constant term. That means 2 is our x term. That means 3 is our x squared term. So we just bring it down. This is x squared plus 2x plus 1 minus 9 over x plus 2, which is the original divisor. What do you guys say? Faster or not faster? I like synthetic division. Only little problem. You guys ready? Put a little star next to it right here. Of course. So synthetic division only works if your divisor, which is this guy right here. Here's your divisor, is a linear term. Okay, so you can't use it for x squared plus 2. In fact, we didn't ever use an x squared. Still, huh? Okay, we've got 2 more to do. Let's actually do this. Let's do. Correct. Yeah, we got to do 2 more problems before we leave here. Got about 4 minutes to go here. So let's do this here. Let's do example number 1 in terms of linear synthetic division here. So example number 1 was, can you divide 6x cubed minus, what is it, 19? It was 19, huh? 19x squared plus 16x minus 4 by x minus 2. And then put a little star next to it, synthetic division. Okay, let's do synthetic division. All yours, you guys. 20-second head start. 3 minutes left. I got to show you this problem and another one here still. All right, just because I have to go fast here, let's see, x minus 2 set equal to 0, which means x is equal to positive 2 is my number on the side. And I have 6, negative 19, plus 16, minus 4. Are we good? All right. 6 adds with nothing. Technically, there's like an indivisible 0 here, so just 6 comes down. 2 times 6, 12. Good there? Give you errors if you need to. There's that. And the multiplication is this right over here. Answer on the bottom is? Thank you. -7 times 2. -14. 16 plus -14. 2. 2 times 2 is 4. And voila, we get a 0. Done. Okay, no remainder. Can you write the remaining polynomial that's left? 0 for the remainder, right? But then this is our constant term.
Oh.
This is our x term.
It's x squared minus 7x.
Awesome. I like synthetic division. Okay, one more. We got to do one more. Sometimes these guys are not linear. That's the problem here. So, example 7. Divide 6x cubed plus 10x squared plus x plus 8. I'm going to divide it by 2x squared plus 1. Plus 1, sorry. Boom. Whoa, that's a problem. So first things first, can we use synthetic division? No, we got to go back to long division. We have this on our hands, and we start off like this now. Okay, that's exactly a minute left. Let's go with it. Long division, a little bit more tough. Let's see. 2x squared times what gives you 6x cubed? 3x. It's all the way over here now. 3x. Cool. Okay, so 3x times that gives you 6x cubed. 3x times that gives you, oh, that is so funny. Look at this. Really needed some space here. We can't put underneath x squared because there's nothing underneath x squared. So we subtract, or in fact, add the opposite. That's gone. But notice, yeah, we have a -2x, right? But that's not our leading term. What's our leading term? 10x squared. That comes down. And you might as well down and put the plus 8 now. So 2x squared times what gives you a 10x squared? +5 or a +5. That's cool. So now we go with 5 times 2x squared is 10x squared. 5 times that, whoa, that slides underneath the 8 this time. That's weird, okay, but we got to subtract or add opposites. That's gone. What comes down is a -2x plus 3, is that right? Okay, in this case, our final answer is 3x plus 5 plus a -2x plus 3 over 2x squared plus 1, and we are done. Okay, you guys can do the homework up to. Yeah, 2.2 is due today, but homework right now is up to, you guys can do up to 31 for the homework. The 2.3 homework up to 31. So the homework will handle the rest later. So I know what's going to happen now. I think we're going to take a test after Thanksgiving. Since we're only halfway through. 2.3